This next video on the tin terrain system is a bunch of segments of videos of me performing different tests as I check out the subsystems in Unreal Engine to validate and make sure that all of the different systems for foliage and collision and occlusion and other features all work fine with the Unreal Engine editor. In this segment of the video, I'll be discussing importing the individual tin tiles and setting up the collision or nanite on them. I'm just going to do a temporary view here, or a temporary workflow of just one of them, so you can see what needs to be set up on it. So I'm just going to create a new folder here called temp, and I'm going to use that to import into. So what you would do is you would take your set of 256 up to 4096 tiles, whatever size you've got. I'm using alias object file format, and you would essentially just drag those into the editor, import them. The default settings are usually all good, and then it'll be imported in. Now what you want to do is load that details for that mesh item. Scroll down to the collision complexity and change it to use complex collision as simple. Save that, and that's all that you have to do for setting up collision on each tile. Now the next option, if you want, is if you're going to use Nanite on it. If you're planning on using Nanite on it, you would enable Nanite. Then after you've enabled Nanite, you need to go back into the properties again. And in the Nanite settings, you need to change the fallback target to %triangles and set the fallback triangle % to 100. Now, if you're doing a large set of meshes, what you would end up doing is you would use under the asset actions, you would use the property matrix, edit selection and property matrix. Now, the issue with doing this, though, is you have to know what the property is, because you have to type in the name for it, because most of them aren't there. So, for example, if I go to collision, I can see my collision complexity is set to use complex collision as simple. And if I go to fallback, you can see that I've set it to %triangles. We need that at 100. And that's how you would end up doing it on a full set of meshes. But Unreal Editor is quite slow when you're using the property matrix. But that basically takes care of collision and nanite on the terrain system. This next segment is on using culling distance volumes with the tin terrain to actually perform distance culling and remove the farther tiles from being viewed for optimization purposes. So the first thing we need to do is actually add in a cull distance volume. So I'm going to actually put that at origin. So I'm just going to zip into the origin location here. Drag a cull distance volume in, and I'm going to set its size, the scale, large enough to encompass the terrain. So I'm going 100,000 by 100,000 by 10,000, and you can see that the cull distance volume easily covers our entire terrain section. So now let's go back to the player start, because you actually have to go into play mode to actually see what this does. So now if I go back up to the cull distance volume, now in order to get the tiles to be culled, the size of the values that you use for the size property will be based on the size of the tiles that you're using for your tin terrain. So in the case of me using large tiles, 1 kilometer tiles here, I'm just going to use an excessively large size and a large cull distance to actually visually show you what happens. So I'm using 10 million for size and 100,000 for the cull distance. So now if I go into play, you can see it's actually culled a whole bunch of the terrain away. Compared, this is what it looks like normally. And this is what it looks like culled away. Now the values that you use, of course, are going to vary depending on how much optimization you want for the amount of culling that you want on the terrain, as well as the size of the tiles that you're using. You can see them popping in there. So you can use this optimization to actually get a higher frames per second with the optimization culling for either world partition streaming or with the culling distance volumes. I typically get about 220 frames per second or greater on this 16 kilometer by 16 kilometer terrain. Now you can see in order to be able to make that have less popping in it, you would actually use better adjusted sizes. I'm just doing it extreme amount to actually show what is actually occurring in the process. So that just shows that culling distance volumes works as well with the tin terrain. In this segment of this video, I'll be discussing world partition optimization with the tin terrain system. You can actually use World Partition's cell system to split the tin terrain into regions that can be loaded and unloaded, just like you can any standard static mesh. Now if we take a look here, I've got my 16 kilometer by 16 kilometer tin terrain system loaded. I'm using just a single texture on the terrain. And if we look in the outliner here, we can see that all of the static mesh tiles are loaded into memory. Now the first thing that you need to know is to get the streaming working correctly with static meshes, they have to have their spatial loaded property set. And in the case of static meshes, by default when you import them, they are spatially loaded. So all of these tiles, these tin tiles, will all work correctly with World Partition because of that. You don't have to make that change to make them spatially loaded. So we just go to the World Settings, World Partition Setup, and Enable Streaming. So I'm going to enable streaming, and I don't need to refer to the documentation. So now you can see all of the tiles, all the static mesh tiles have all unloaded. Now I can go over to the World Partition minimap, and if you can see the 16 by 16 static mesh tiles that are used for the terrain. If I go in here and just right click and load a section, you can see now I can load just a small portion to be able to work on or to be able to view within that large 16 kilometer terrain, which helps optimize things if you've got a slower system. And you can see, if we look in the outliner again, you can see the tiles that are loaded and unloaded. I'm just going to unload this region again. Now, when you go to play this, because the player is an actual streaming source, it'll actually stream in the cell regions of World Partition automatically for the player. So if I go into play, you can see now we've just got a area of cells that are loaded that are set by what the cell loading distance is set to. So if I go in and do a slow-mo 4, so that we're running a little quicker. This is just going to take a couple of minutes here to show you. You'll be able to see the tiles loading in because I'm the player streaming source, so they're going to end up loading in these tiles as I move towards the new areas that are not loaded yet, and they'll load in. You'll see them popping in here as soon as I get far enough over. Because each one of these tiles are 1 kilometer in size, it actually streams a fairly large amount of region in for the world partition cells. There you can see some just popped in there. And as I continue running around the map here, we'll get more areas of it popping in. So you can actually optimize the tin terrain system the same way that you can optimize any world partition system to be able to use the streaming for loading in areas of the terrain. So you can basically set your view distance that you want using the streaming system. Now, one thing to keep in mind is that this specific tin terrain that I created here, I used 1 kilometer size tiles. You could actually use 512 meter size tiles if you wanted to instead, and then that way you're actually going to, there's another area just popped in. That way, if you use 512 meter instead of 1 kilometer tiles, you'll actually be able to have a finer control over the amount of streamed in data. There we go. Now it all just popped in. You'll have a finer control over the streaming size, as well as things like the frustum culling will actually be able to cull on a smaller section, which is why if you look at landscape in world partition mode, it's using 511 by 511 component size so that the streaming amount and the frustum culling, etc., can be on a smaller section of a terrain. And that way you end up having more control over the size and the optimization as opposed to a 1 kilometer. The only catch, of course, if you do that is if you go with 512 meter instead of 1 kilometer, or 500 meter instead of 1 kilometer, is the number of tiles that you're going to be dealing with is going to be a lot more. So it's going to take you longer to do things like put materials onto the tiles, etc. I'm going to see if I can work on some plugins that will help with managing textures and materials for the tin terrain tiles. I'll have to see how that goes. But as you can see here, we're streaming in and out with world partition using this system. This video segment is just a proof of concept to see whether or not an auto material similar to what would be used on a landscape can also be used on the tin terrain. Right now, the terrain is using the single texture material that I created before, which is nothing but a diffuse and a normal map applied to the base color and normal. So it's a single texture across the entire terrain. What I have done is I created a very basic auto material that has a macro texture, a rock detail, standard rock with sizing and or UVs, and a standard grass with 2 near and far sizing UVs. What I'll do is I'll make this material available for people on the Google Drive so that they can have a copy of this material. But if I go in now and select all of the tin static meshes, there we go, got all 256 of them, and just drag the auto material onto it. Now, one difference with static meshes and tins is this material will apply instantly. It's not like landscape. It doesn't take an hour to apply a material. This goes on instant. And you can see now I've got a really nice auto material with grass and rock on my terrain. And of course you can make this into material instance and access the parameters for the tiling. This auto material could also be expanded to have snow-capped mountains, additional macro textures to get rid of tiling, whatever you wanted to do to make it into a better auto material. This proof of concept just shows that auto materials also work on tin static mesh terrains. This segment is discussing one of the other features that will work on the tin terrain system, which is the mesh sculpting system that is in Unreal Engine. So for example here, if I select one of the tiles of the tin terrain, which is a 1 kilometer by 1 kilometer tile in this case, I can actually go into modeling mode, and I can use these tools for mesh deform and painting and sculpting to actually modify this mesh. So for example, if you had, after you imported and created your tin terrain, if you found that you had some spikes in the ground that you wanted to get rid of or reduce the severity of the spikes, you can actually go in and edit the vertices on them. I'll make this into a smaller brush. Now you can see here I'm going to edit this section here of the tin terrain, and I can actually just click here to actually sculpt and change the shape of the terrain. Now there's a whole bunch of different tools in here in the deforming and modeling section. Best to consult the Epic online documentation for what they all do. After you actually perform some vertex sculpting, they say that sometimes you have to repair the normals on the vertices, so you'll have to read the documentation and see what it says on the full sculpting workflow. What I will probably do in the future, if everything goes well, is I will make a sculpting video in the future that goes in depth into using the system for doing sculpting. This next segment is on procedural foliage spawning. I went into the editor preferences, enabled the procedural foliage. I downloaded a Megascan set of plants, and I also have some grass from the kite demo. And I created a procedural foliage spawner. Now if I drag that into the map and increase the size of it, now in the procedural foliage spawner I actually added in the grass and one of the bushes into it. All the rest of the properties I have basically kept at defaults for right now. So if we go down to resimulate, now you can see, there we go, we've got now plants, foliage on our tin terrain system. So the entire procedural foliage system will also work with the tin terrain. With the Quixel foliage that's available, there should be a lot of trees and bushes and grass that you should be able to actually fill your world out with. But this also shows that the procedural foliage spawner does work with the tin terrain system.